So today I'm gonna be solving starter 73 of CodeChef. I'll try to solve as many questions as I can. So the main aim of the video will be to show you people to how to approach a problem and like think about it. So let's get started. So this is starter 73. It's like div 1, 2, 3, 4. First I'm gonna start with div 4, right? They're like 1, 2, 3, 4, 5, 6. The first four problems are in div 4, then I'm gonna switch to div 1 directly because the six problems are same, right? So going to div 4, like I have written all the names of these problems, whatever these are, right? So let's go. Let's see the problems. So first problem is chef plays Ludo. So in this problem, so if it is simply written like if chef rolls a Ludo, if it is 6 on the die, he can in the current turn if it's a 6 on the die into the play. Simply like we have to see if he can enter a new token or not into the play. Like simply if we are going to check if the input is x, which is 6, we are simply gonna see out yes or no. So int x in x, simply if it's going to be 6, we are gonna see out yes. Simply otherwise we are gonna see out no. So like this is basic ternary operator. So like it is an easier way to solve this. So like this is a very easy question. It probably will get accepted. Going to the next question. Multivitamin tablets. The doctor prescribed chef to take multivitamin 3 times a day and chef has already 5 multivitamins. Determine if chef has enough tablets for these X days or not. Achha, okay. So simply we're going to go to the next question. Yes, so we are going to simply take X and Y input. Simply we are again going to use the ternary operator. If y is greater than equal to 3 star x, we are simply going to see out yes, else we are going to see out no. Simple, easy peasy question. And we are going to, yeah, these questions are very easy. No one should have problem in solving these. Let's see if it gets accepted. Yeah, it probably would get accepted. Yes. So now going on to the next question. Chef calls a lucky number if it contains the digit 7 at least once. So we have given a number, we have to determine it as lucky number. So how we are going to solve this question is that, like first we are going to take index x. We will create a flag. Simply, what does this flag do? What's the purpose of this flag? Like if it remains the same, will see out a particular thing, otherwise we see out a different thing. What we want to do is we want to go through each of the numbers, each of the digits of this. So while that x is greater than 0, because we'll be checking the remainder and dividing it by 10 so we can check the next digit. So at a particular time it is going to get 0. While x should be greater than equal to 0, what do we want is that, see if, what should flag be? If x mod 10 is equal to 7. Simple. What flag is telling is it's a lucky number or not. What this is doing, this is going to take a value from this and put it into this. If the remainder is 7, the flag is equal to true. If we get the flag equal to true, we don't need to check anymore, right? We simply return, we break off this loop. Yes. And otherwise we divide it by 10 and keep on checking. And simply you're going to see out. See, if it is true, we have to print yes, right? Let us see. Otherwise, if it is a lucky number or not. So simply and if it is true, we are gonna simply see out yes, otherwise we're gonna see out no. It's a very easy question. Control S, Control C, Control V. Let's see it if it gets submitted. Yeah, it's a pretty good question. Like the logic was very simple. We are simply checking through each of the digits. Let's see if it gets submitted. Yeah. These questions are very basic, like everyone should be able to solve it. Now like this question. After this question, we are going to go to division 1. Now we are going to go append for all question. One second. So in this question, we are given an array, right? And first, we have to append a non-negative integer x to the array so that the bitwise OR of the entire array becomes y. And we have to enter the minimum possible value. If not possible, x. See, like in these type of question, generally or type of bit type of question, there is a very amazing property, important property, that is like if we want to make a something by doing OR of two numbers a and b, or should be equal to c. Both a and b should be submasks of c. But that's very important property. Generally, that's how we check. So what we're gonna do is like if we take like OR of all these elements, like first thing it should be a submask of y. Simple. If it is not a submask of y, simply we're gonna output -1. If it is a submask of y, we'll like simply subtract it. Like easy peasy. So we are gonna take in y, and we also gonna take o which will be our OR values for our value. Same. So we're gonna take vector of int. We are gonna take in value. As we are gonna take an input, we don't even need to make an array. We don't even need to make an array. We can simply take the elements as an input and keep on doing all because we don't need to store them. We are just wasting space. But for you, like I'm like explaining, so I'm doing it all. So how we're gonna see out is like if O 0, see it should be equal to y. So should be equal to y. What is happening is like if the OR of all the elements except x is something, the OR with the y should be equal to y, because if it's not, then there is some bit which is set in O which should not be set. So otherwise we're gonna see out -1. Else we're simply gonna see out y minus O. Let's see. Okay, what's error? Control C. Yes. Like if it gets submitted, then also like if someone doesn't get why I did y minus O, see like if O is equal to 8 is 1000, right? No, 8 is it's 1000, simple. And let us assume y is equal to 15, 1111. So what should be number which should be added is y minus O. Simply the rest part should be okay, it got submitted. So like these are like the Div4 easy questions. Now let's start with Div1. Like from here, like the nice questions begin. I'm gonna take a water break. Just 2 minutes. So let's go. So we are given an array A of length n. We can perform the following operation: select an index and select an integer. And set ai is or I, and ai plus 1 ai is or plus 1. We have to make all the elements of the array A equal to 0. right? So what we are given is, see, if we are given A, B, C, D, A, B, C, what we want is we want to make it 0 or something else. So what we're gonna say is there are two property, like 1 XOR 1 is equal to 0. We can use this, like expanding it, it will be A XOR A, which is equal to 0, making that element 0. Also, one more property, 1 XOR 0 is equal to 0, 1, like simply just telling you. So what we can do is, like, if we XOR the first element with A, we have to XOR the second element with A also. Let's do it. It will be 0, A XOR B and C. And then we do the same thing by using B. A XOR B, not B, A XOR B. So it will become 0, then it will be A XOR B XOR C. Now two cases arise. If the number is an odd element, see, in question it is not said that we have to make them 0. If it is an odd element, for the first two elements, let us assume this value is x, we can simply do a 0 XOR x. We're gonna get that particular value, like 0 XOR a is equal to a. Simple. But if it is even, then the only possibility is that A XOR B XOR C XOR D should be equal to 0. I'm gonna let it be there. So let's assume, so we have taken the test cases. Int n comma x is equal to 0. X I'll write for the XOR of element. Don't take x equal to 1. Okay. So we are gonna make a vector. And we are gonna simply gonna take an element. We actually didn't need to take an element. I'm just taking x XOR equal to a of n. Simply, what we're gonna see out, if n mod 2 means if it is an odd number, like if it is an odd number, it will return 1, and if it is 1, it will go into this ternary operation. Now if it is not an odd number, then we have to check if x equal to 0, then it will be yes, otherwise it's going to be no. Simple. It's pretty easy question. Let's see. It will get submitted. It's very easy. I'm thinking like next 2-3, well, 1 or 2 at least will be very easy up to C. I hope so. Let's see if it gets submitted or not. Okay, it gets submitted. Pretty nice. Now let's go to the next question. So going on to the next question, find an integer. We have to find an integer now. First I'll take the input int x, y. We have to take int x, comma y, same x, y. We have to find an awesome integer, right? We have to find something awesome, n, such that n plus y divisible by x, n plus x divisible by y, and n is less than or equal to 10 raised power 18. So like n is 10 raised power 18. So what we can do in this, like this is like basic maths, like basic observation maths. See, like we have to make something divisible by x. What's the possibility that y, which is given to us in the question, is a multiple of x? It's very low, so we can't depend on possibility. So n should have minus y in it. Well, that's for surety. And these are symmetric functions, like in maths we used to study symmetric functions about x axis, y axis. So simply n should, int n should be minus x minus y. Well, that's for sure. Now if it's minus x minus y, but in the range we are given that x, y, 10 raised power 9, and also n is greater than or equal to 1. So obviously minus x minus y is going to be less than 1. Obviously it's negative number. So what we do, while n is less than 1, we are simply gonna add n x star y, basic, and we are simply gonna see out, and it's simple. And as it's up to 10 raised power 18, we're gonna do this. We're gonna change into long. Yeah, I think like for me, like this is most easy. This is even easier than the last question. Like for me, when it's like basic maths question, n is less than 1, n plus like it's good, matlab, most probably it will come. So like now I think the difficulty of questions is gonna increase. Till then the questions were very easy. Matlab, you can see like the level of question is very low. So, okay, it got accepted. So how many questions I have left? 1, 2, 3, 4. And how much time it's going on? 15 minutes. See, I'll try to wrap it up in like less than an hour. Okay. Now we are gonna go to the next question. Minimum or path. I have to read this. Matlab, first, Hershey's has an array A of size n containing non-negative integers. He starts an index 1 and wants to reach index n. In one move, he can do the following. If he is currently at this index, he can move to any index if that j is greater than equal to I less than equal to mu I plus n. Cost of the path is the beta dimension of all elements. So we have to determine the minimum possible. Yes. So first, I'll just take in the input. Yeah, that much I can do. Right. Yeah, I took the input. So in this question, it is said like if we are at an index I, we can jump to an index j such that j is either not going out of the bounds of this array or the particular value at that index I. We can take as much jumps, and we have to like minimize the OR value. So like minimize the OR value, no? Binary search. See, like generally in minimization question, we have to use like binary search, dynamic programming, maybe some greedy approach. But here we are dealing with bits. So like let me see the constraint. It's like 5 into 10 raised power 5 now. So 10 raised power 5 is like 2 raised power 16, and multiply by 5, 19 bits and 19. So simply we can like traverse like see. Yes. Like if we have a particular answer like, of all these values, right? The first and the last index should always be submask of that answer. As I told in the previous question, like because we are always going to be at the index 1 and index n, right? So they are always going to be submask of that. And what? So like yes, we have to. If it is, say if it is not possible, then it will be not possible. Let us assume that all the bits are set, like 19 bits are set, like maximum number can be here, so 19 bits are set. It is not possible only when the 19 bit is that particular value. The submask, A1 and AN are not submask of that 19 bit. And simply then we are gonna like decrease the number of bits and simply we're gonna get the answer. So it's like it's like a Bitmask question. Also, yes, we have to take care of the previous statement. It's like a DP Bitmask question, DP with Bitmask. Yes, that's a very important topic. So I'll try to solve this. It will probably be very easy. Let's start it. So first we're gonna take a mask. 1 or 90, or 1 or 90. See, when we do, for the people who are just like beginners, like 1 XOR, 1, this of whatever operator it's called, -1, it will give us X bits, not, because when I started, I also have confusion like this. It is going to give us X bits, not X minus 1 bits. Simple. So simply we are going to make a function which is going to check if this mask is valid or not. We are going to pass in this and this. There is no need to pass in the array like if I made it global, but I am just passing it for convenience. So if it is valid, then no problem. But if it is not valid, that's the case, we are gonna see out -1. Because if all the bits are set and even still we can't reach that particular value, yeah, it's mask. My bad. Then obviously it's gonna, we're gonna see out -1 and then we are gonna continue. Continue this. like basic question, and this is valid function is gonna return us bool is valid. It's gonna take an input of a mask and vector of, I'm gonna pass it by reference. We are obviously not gonna change the vector, so like it doesn't matter if we pass it by reference or not. So now what we're gonna do, like in the end we just have to see out mask, like that's for sure. We are gonna traverse through all the 18 bits, I is greater than equal to 0, I minus minus. Now we have to switch that particular bit off. How we can switch this bit? Like in the previous video, we learned that if we do 1 XOR 1, it will give a 0. So that's what we have to do. We have to XOR the mask with 1 XOR I. Simple. It will switch that bit off. Now see, if after switching this bit off, if it is valid, then no problem. But after switching this bit off, if this function returns as false, like false or false is true, right? So simply we are gonna set this bit again, because without setting it, we are not gonna get the answer. Like simple, like basic we have done. Like int will work, right? Int will work in this question. Let's see. Now we are given the vector now. So simply, like the basic condition is like the zeroth, and like the base condition is the zeroth element of this array and the last element, a of n, right? So n is equal to a dot size. Simply if a of 0 is all equal to m, okay, is a of 0 or m is not equal to m, or a of n minus 1, right? Or m is not equal to m. We are gonna simply return false. We will make a 1D vector of booleans to store DP value a dot size false. See what this is telling us with that particular mask, how many elements in this particular array can we reach. Simple. DP of 0 is always gonna be true. 1, true. It's boolean, cause we are starting at the 0th index, na. It's the first, it's 0 indexing, so don't get confused on that. And in the end, what we have to simply return DP of n minus 1. Like if we can reach, if it is false, we can't reach it, it will be false. Now we are going to traverse to each of the element. See, generally it will be, let me try first. Okay, there is one more, remove this. So, what we have to check for that particular element, if it is a submask or not. Yes, we have to first check that, that is very important. Is equal to m, right? If it is a submask, if it is not a submask, we are simply gonna continue. Yes. Also not being a submask, if it is a submask but we can't reach it with the previous values, or simply saying the DP is initially false, na? So yes, not equal to DP of I, which means we can't reach it from the previous values, na? Like if it is negative, which means we can't reach, already it is set to negative, true. So if we can't reach, that doesn't matter, it doesn't even matter if it is a submask or not. We are going to continue in both of these cases. Otherwise, what we're going to do, we can either go up to I plus a of I and n minus 1. Yes, it's 0 indexing, na? So we'll see which is the minimum of these two. Now what we want to simply, we are going to simply see the Bitmask thing again, like we'll make a for loop, k is equal to 0, k is less than equal to j, k plus plus. Okay, k plus plus. If a of k mod m equal to m, then we are gonna set its dp equal to simple. Let me think one second. If I travels through I01, why I'm going to, yes, one more thing we can do here. Yes, like k equal to 0. Like, why should I traverse again and again from the start, right? You see, what's my point here? Okay, I have to put a semicolon here. My point here is that if I've already said that we can reach that particular and it's a submask, why are we again checking for that? Like, it's like DP optimization basically. So it's gonna return true. Like, basically it's all good. I don't think we have to make it long. Well, I'll see. If the code doesn't work, I'll try making it long. Like, or if I have some other mistake like is not equal to 1 or return false, we made our DP boolean 0, base condition continue, we are gonna traverse k plus plus. I think it should work. Matlab, summation is cleared. So I'll explain it once more. So what I did is simply taking a mask. It is going to be 1 up to 19 digits. If simply I'm checking if it is not valid, means we can't use this to go from 0 to nth element. So simply I'm gonna return -1. If it is possible, then we are gonna switch each bits one by one. 18th bit, 17th bit. See, it is 18 to 0, which means 19 total. So like that, simply first we're gonna switch off. If we see that after switching off, it will work, then no problem. But if it will not work, false, true, we are gonna again on it. And in this function, first let's do, okay, what's the problem? Okay, let me try that once. Yes. So where was it? Yeah, it shouldn't get, like, if there will be some mistake, I'll see. So in the isValid function, we have a particular mask and a vector. We are not changing the vector. I just passed it by reference. Simply, what we first we're checking the base condition that the 0th. Okay, I did a mistake here. Yes. It should be in brackets. Yes, some operator crap, I guess. Yes, how can I make this mistake? Like, did I make it here? No. Yeah, it's probably gonna give wrong answer. Yeah, like such a silly mistake. So we are gonna check if, like, like operator precedence. So simply checking that a of 0 is a submask, a of n minus 1 is a submask, we're gonna return false. If it is not a submask, we are going to create a DP in DP of 0 true because it's already at that element. For each element, we are going to check if that is a submask or not. If it is not a submask, we are going to continue. If it is a submask, but it should also be that DP should exist, because if we can't reach at that position, then it being a submask is meaningless. We are going to see the array range of J, and then we are going to traverse simply. We are going to make all those DP true. We make it global so that we don't traverse it again. Okay. So, like, what's the problem here? Let me see the problem and like what are the issue. Is not equal to n a of n minus 1. It's true. Victorian a dot size holds dp 0 to I 0. If okay, my fucking god. Like, it's very annoying now. Like, if you like write all the code and they're like such silly mistakes. Is it somewhere else? I think no. Yeah, it should work. I've got like wrong too many times now. How many times I got wrong? 1, 2, 3 times. Probably 4 times I've got wrong. Okay, it's working. Yes. Okay, it's a nice feeling. So now we'll go to the next question. First to last, and then to, yeah, these two are gonna be like very difficult. Okay, this question is done. First to last. Let's see. I'll take a like water break of 2 minutes. How much time is? It's like 30 minutes now. Let's see if I can solve 3 more questions in 30 minutes. We are given a grid. Generally, grid questions are graph related. Uh, so we store it in like matrix or adjacency list, whatever you want. So chef want to move from his current cell to an adjacent cell. So he can move in all four directions. And there are special cells through which we can move corners. And we want to find the minimum number of moves to go from 1 comma 1 to n comma n. So simply you're gonna do like BFS, like it's gonna be like very the constraint given here are as 10 raised power 9 now. So we can't do BFS, right? It will be 10 raised power 18. It's not gonna work. K is given to be 10 raised power 5. So like from the constraints, I can see like we have to do something with the special cells. So let's see. Matlab, first I'll take the input. What was the input? NMK, and for XY we are gonna take int n comma n comma k, same n same k, vector of k of int comma int. I'll call it, what should I call it? A B C. I'll call it int. So simply you're going to take input for int I is equal to 0 I is less than k. You can make adjacency list or something like that also, that will be. So we are going to take int comma x comma y, same x comma y, and we are going to push it. We are going to push my x comma. Achha, these are the coordinates of special cells. I didn't even read, I just took the input special cells. Now what will see like how I'll solve it, like I'll take an example like dot. So like that's the only way to solve. Like if you can't like think directly, you have to take the example 1 2 3 4 5 6 and dot like star star. Okay, I think I did this. And we're gonna take here some, and that's it. And then we're gonna take one more. So I made something random. Like versus 1 2 3 4 5 6 7. It's case special set. Like I just take a random case. That's the best way to think. Like making a grid is more visualizing 1 comma 5 3 comma 4 5 6 7 8, right? 2 comma 3 4 5 6 1 comma 1 2 3 4 5 6 7. So what are the things we can observe? The first thing we can observe, we have to go from 1 comma 1 to n comma 1. So from 1 comma 1 to n comma n, we have to go to n minus 1 columns, n like n cross n. So n minus 1 rows, whatever like or whatever. So simply answer will be n plus n minus 2. Like that's like basic. Now if we use special cells, obviously if we are gonna use special cells, we are gonna use it to come right and down. So number of special cell used. Now what's the thing, like the best thing I can think is if I use 7 I can only use 8, right? But if I can use 1, then I can use 3. I can't use older ones. So from observation it will be 1 3 6 7. Yes. So what we want to do is we want to like the use maximum number of special cells we can. Obviously, if we want to minimize this, we will maximize this. That's like basic. Like if we use particular special cells, we are not going to be able to use the special cell in that row or behind all the columns behind it. Like if I use this row is gone and all this on the left of it. Sorry, this part. I can't use anything. So what we're gonna do is we're gonna try to use as many cells. Like if in a particular row, like if I took 7, like if in this I took 5, then it's better to take 1 now. Like the in a particular row, the minimum as we can. But that minimum, we should also make sure that that minimum is not less than the previous minimum in the previous row, like all because we can't go to the previous column na. So simply like if it's like if we write it like this row wise 3 comma 8 2 comma 6 1 comma 7, if find the LIS of it, it will be 1 3 6 7, right? 1 3 6 7. So like this is going to be the answer simply. Like I don't know, like if it is 2 here. Yes, there's one more problem. See, the problem is that like I should make sure that it should only use it once in a particular column. So like if I change the order of the columns, yes. So what can I do is 5 comma 1. Yes, like this is the best thing we can do. Simply change the order of the columns. So, yes. So simple. Yeah. So simply we're gonna put all the k values in a particular vector, and then we are gonna find the LIS of it. Like basically that's what we're gonna do. So simply let's start. We are gonna sort this a dot begin. Like for those of you who don't know the comparator function, I'll tell you here. There are many techniques. You can make a comparator function and then make it here. What I use the lambda method. I don't know whatever the hell it is called. So simply first in the this is going to be the input. I'm gonna write pair of int, comma x, pair of int, comma 1, right? And this is gonna be a function. And then we put a. And how to write this is what I want. If they are of same rows, then we see the columns. But if they are of different rows, means x dot first is not equal to y dot first. They are of different rows, right? So simply we are going to sort them on the basis of rows. We are going to return x dot first less than y dot first. What this means is if they are already in this order, like 1 and 2, first row and second row 1 and 2, it's gonna be no problem. But if it is order is like 2 and 1, it's gonna return false and it's gonna switch it up. Otherwise we have to simply return on the descending order of the columns. So x dot second is greater than y dot second. Simple. So this function is done. We are gonna make a vector of int of special cells. I'll just call it cells, and it should be of this size. Simple. And we are gonna put a dot size a plus plus cells of I is equal to A of I dot second. So we are storing a pair now, so like it's simply, and then we are gonna see out n plus n minus 2 minus lis of cells. Now lis is simply longest increasing so I haven't made that. Okay, I'll make it like that. So this should return us this function. We are going to take it input vector int of, let's call it int. Okay, what's the problem here? Identify lis is undefined. So what that has got to do with this? Bullshit. So simply, like there are many approaches. We can use the dynamic programming approach. I'm going to use the lower bound approach. So this lower bound approach, it's best when we just want to find the size of the layers. Means we make a vector of int of answer. We have to return the answer dot size. What we want to do is we use the auto operator. See, auto operator is very amazing. Auto operator ampersand C in a. What we check if in the answer vector we are gonna check the lower bound answer dot begin. If in the all of the answer vector we have an element which is the lower bound simply. So like we are gonna check like the elemental which is like for like if it is 10 22, right? If our element is 9, the lower bound is gonna be 10. See, if it reaches to the end, it is equal to answer dot end, which means there is no element which is lower bound, right? Means all the elements are smaller than it. So simply we are gonna do answer dot pushback C. I think there were two backside of this question is like maybe it does not give you the proper LIS array, it just gives you the proper size, and one more thing is there should be no unique element. Else we are gonna put that value equal to C. Simple. Let's see if it works. Like this was a very easy question. Comparatively, it's easy. So we make a vector, we pushed in special cells, and we sorted it on the basis of degree. This method. Simply you subtract LIS. I think I have written it properly. Auto is this. IT is equal to answer dot end. We are gonna push back. Else we are gonna this. And then we are gonna return the same. Let's see if it works. How much time has gone by? Okay, 43 minutes. It's gonna be more than 1 hour. Wrong answer? Okay, I got some right answer, which means like my code is good. Maybe I'm missing some base cases. Test cases, no problem. K0, K can be 0. If K is 0, then it's simply gonna cells, it will be empty, no problem. X less than equal to ny. Yes, one issue is here. Our cells, it should not be on the corners, means like it should not be on the last row or the last column, because then it will go out of bound. Well, we don't want to go out of, we don't want to use them. Like it could come in the answer, but that might give us wrong answer. Yeah, I think this was the issue here. Let's see. This was an easy question. Like the takeaway question is to be able to visualize the answer. Like that's it. Like that. Now only 2 questions left. I think these are gonna take a lot of time. Lot of time. Probably half hour more. Yeah, I should open both of them at the same time. I'm recording now. It's already heating up. So it's elevators question. Elevators. It's pretty nice. In 45 minutes, I solved like 8 questions. I'll probably guess if I am able to solve these 2 questions, like it will take me 20 more minutes, 20, 25 to 30 minutes to solve all of this, well, if I can solve. So let's read the question. I'll take a break, 2 minutes. Okay, it actually looks very huge. So it and it's rating 2715. How many people solved it? 52, and that's Hamiltonian tree one. Okay, so statement. Yeah, what's the problem? That's so in this question. Actually, the clock on my computer is wrong. It's not 12 a.m. actually. It's actually 1:32. Like 1:32. It will be finished around 2 p.m. or 2 a.m. So, uh, so there is a building with 10 raised per 9 floors. First, I'm gonna do hash define a long block. See, I don't want it to be cause me any problems later. Labeled from 1 to 10 is per 9 from bottom to top. And people would like to move up several floors in the building, especially the highest person wants to go from AI to BI. So simply what you can observe is everyone wants to go up to a larger floor, all the I persons and people. And there are elevators in the building. An elevator can hold any number of people. Initially at the 0th second, all elevator at the 0th floor. At the first floor, not 0th floor. An elevator takes 1 second to move up a floor, but cannot move down any floors. Okay? On any floor, an elevator may stop so that the people may enter or exit the elevator. Each person takes h seconds to enter or exit an elevator. Two or more people cannot exit or enter the same elevator at the same time. They must wait for their turn. Okay, so like if it is H plus H plus H like that, a person can exit an elevator on any floor, not only floor BI. So like that's your choice, but why would we want to exit on a floor? Like if an elevator is going up, on exiting will take H seconds, and if we want to take another elevator, it will take another H seconds. That will be wasting 2 H seconds, right? We can reschedule the destination after H second to exit an elevator. Okay, so simply why would email? That's like a stupid one. It is given to confuse. Why do we even want to exit? We have to find a minimum number of time. It takes all pen to reach the destination exit optimally. And the constraint h is given to 10 raised power 9, 10 raised power 9, 3 into this. First, I'm gonna take in input basically in NMH. And NMH. And then we are going to have vector of A and B. Vector A of N. A of R is equal to 0, I is less than this. What it's the acha. So what now what are the things which I can observe from in this problem? I'll write it. Generally I would have used pen paper, but like I can't show it on screen, so I'll have to write it. What are the things we observe is everyone wants to go up, right? H is this. First let me find the maximum time it can take. Like, cause if the time is infinite, na, so we'll obviously reach it. So we'll find a particular maximum time it is gonna take. Like for the worst case, it is like sum of n over all test cases, na. So if we're gonna t is equal to 1, we're gonna n equal to this. We're gonna take a single elevator, and 3 into 10 is per 5, and we are going to take everyone start from AI 1 and reach to this 10 raised power 9, 10 raised power 9 minus 1 floor, 10 raised power 9 minus second floor. So simply how much time we gonna take is 3 into 10 raised power 5 people, right? Each person is going to enter and leave, and 10 raised power 9 is the maximum time it can have, plus 10 raised power 9. The second 10 raised power 9 is like if you have to go up to the top, so the it will be 6e14, मतलब 6 star 10 raised power 14. Like this is the maximum time it can take. So simply we have to minimize this time. And minimization I already told, like what are the things we can do: binary search, dynamic programming, some greedy method, right? So it's not a DP question. We don't need to even care about all the previous anything. So like it screams like binary search. We have to minimum time. Like the binary search, minimum time can be 0, I guess, and the maximum could be. First, I'm gonna write this. Int low is equal to 0, high is equal to. I'll take 1e15, just to be safe. Like not take exact value. Answer equal to 1e15. Right. While I'll apply the like basic like template binary search here. While is greater than equal to 0. Okay. Fuck off. So simply we are going to have to see out answer in that. Like we are going to find a mid value, right? Let's call it time. In time, which is equal to low plus high minus low by 2. I do this because sometimes it goes overflow. That's why it's like a better way of writing. If this particular can be solved, we are going to have to find time and AI A, comma B. If it is possible, then simply we have to minimize the time now. Minimum of answer over time. Simple answer. And we are going to y is equal to time minus 1. Else simply we are going to increase the lower bound, as that time is not possible. Simple. And this function is going to return us bool. See, I haven't thought how to solve this, but I write the basic method in time. Okay. Vector of int of ampersand A, vector of int of ampersand B. Simple. Okay, what it is showing here. So like this is, I made the basic template. So what I have to do is now think of the algorithm to solve this. I can say is like if there is an elevator now, it will go from it will go to see yes let's see, if I want to sit on an elevator, I will sit on the elevator which is already going up, right? Obviously to reduce the time. Why would I have different elevators? Like so like I take an elevator, I find the maximum building it can possibly reach while staying under time constraints by using as many people as possible, right? Let us assume at a particular instant, well, some people I have already used up in an elevator. So like it have to reach B of I. It will reach from first, right? This is the time it's gonna take to reach its main position. Let us assume that each person is gonna come and go. So 2 times of the H, capital S, small h, and number of people. It should be less than equal to T. T is the time we assume, right? So the number of people which can take the elevator is people which will be equal to T plus 1 minus Bi divided by 2 star H. Simple. I don't know why it's showing an error on a comment. So simply what we want to do, like this is the maximum people we can have in an elevator. Then what we are going to do, we are going to check for the next elevator. See, we don't even care about the AI values, yes, because it doesn't matter where they're from, right? Because it just matters where they. It doesn't even matter where they want to go. We just want to see for a particular group what's the maximum place they want to go, right? So this is done. We have to use NMH instead of passing. I'll make them global. Yeah, like passing. I think like that's Control X, Control V. Yeah, that's it. Okay, that's done. So we'll sort B dot. See, there are many ways. Like if you want to sort in descending order, we can do B dot begin and then greater operator. We can also make a comparative, well, many things. So what I prefer to do is R begin. It's gonna do a reverse, simple. So basically till now, I made it. I just have to write a solve function. Solve function is gonna be easy. So simply what we want to do, int the count is equal to 0. This count is the number of people which can reach their destination using M elevators under time t, right? I'll write it like in case you forget. Count of people which can reach their destination, right? Which can reach their destination using M elevators in time t. See, if count is greater than equal to n, no problem, we return true. If count is less than equal to n, we return false. Also, like we also have to see now if that particular elevator is possible. It is possible for that particular elevator to, in that particular time which we are checking, is it possible for it to like take those many people? So simply we are gonna traverse through all the elevators. Like in the end, what should we return? I'll see. We need number of people here. What's the number of people gonna be? T plus 1 minus bi to h. That's the number it's gonna be. Now count plus equal to people. So these many people have gone to the elevator. Then we're gonna go to the next elevator. Simple. Also, if count is greater than equal to n, we are simply gonna return true. And in the end, we are gonna return a false. Bi. No, it should not be bi here. It should be count. Let's see if it works. I'll try. It doesn't work, I will see. I don't think it's gonna work. But I'll still see. Count is 0. Then yes, I forgot. If the number of it's not possible. Yes. Less than equal to 0. Yes. Obviously, it's not gonna work. It's wrong now. But how is it even running? I didn't. Simply time has to be increased. See this now. We'll simply see here like b minus. Assume t plus 1 is less than b count. So this, and this is the condition. Simply we got more count we don't need. And if we used all the elevators, right? We used all the elevators, but not all persons can reach. That can also be possible, na? Yeah. Control C. Is it showing time limit X? Obviously it was wrong. Yeah, so like we took input sorted 1E5, time is equal to this, we passed time and answer and time. So yeah, it should work. Most probably it's gonna work, I think. Okay, it's showing the wrong answer. It's showing wrong answer in all cases. How can it show wrong answer on all cases? Oh, okay. Did I really do that? Like that's like it should be able to like sense like there should be a bracket basis on the basis of code. Now, like obviously it's gonna be a bracket. Like count plus people, count is greater than equal. We have to check for count people less than equal to return false, return true. Solve is completely right. Input we are taking the array sorting the large order. We are gonna time minus one, time plus one. Yeah, it should work. I don't see any problem here. We're gonna go to the next question. If it doesn't work, yeah, I'll pause the video and think what's the wrong. Well, I can. Okay, it worked. So very amazing. So like, let's go to the last question. Yes, only one question to go. Hamiltonian tree. Yeah, it's gonna take a lot of time. It's 26% accuracy. And how much time has already taken? Around 1 hour. So this question I think will take me 20 minutes. 15 to 20 minutes it's gonna take. Okay. So it's tree. First let me see the constraint. 2 raised power 5, 10 raised power 8. Like I'll take the input, then I'll rest for some time. Okay. Like 2 minute break, then I'll start again. I generally do this. My version of C is old, so I have to create this like this only. Next n is equal to 2e5. It was 2e5, no? 2e5. I'm gonna add 69 to it, like a lucky number. So I do this. It's a tree, na? So obviously we don't have m because obviously the number of edges is gonna be n minus 1. We can mems. I don't think memset is for array. I don't know. We are simply gonna clear it for the previous test cases, and then we are gonna take an input for int I is equal to 0, I is equal to I plus plus. We are gonna make it 0 indexing, not push back. Yeah, I'll define, yes, I'll do it. Hash define. See, it's very nice to use hash define pb, push underscore back. It's very nice to use macros. Okay. Minus minus y. Yeah, it shouldn't so and adjacency list of y should be equal to. I don't need to do it again. I already made it. I'm just making it 0 indexing. So I have the adjacency list ready. Like basic. Like I should submit this much only. So you're given a tree with n vertices. We have to determine the number of edges you must add to this tree to make it a Hamiltonian path. So Hamiltonian path, right? What a Hamiltonian path is, which goes through all the vertices. Well, a path which goes through all the vertices. So like some properties is like the path is a set of vertex disjoint. It's a set of vertex disjoint paths. Means if there is an edge between 1 and 3, then between that edge there should be no element. It should directly go from 1 to 3. And also one more property, like which is like common sense, like degree of all the elements should be less than equal to 2, except the, well, it should be less than equal to 2. Like this is the basic. Like either an element is connected with one or two elements. Like this is the basic of Hamiltonian tree. Now I'll see the test cases. Vi1 to so test cases. Yes, we are given one explanation. Nice. So for the first tree, see it's simply like DP. Yes, DP question. Yes, because we have to find the minimum value, na. So it's like either binary search or DP. It's like DP on trees. Like if you have weak issues in DP on trees, go to like CSES. There is tree algorithms. Solve those questions. You'll get a good handle of DP on trees. Like in this question, we are given. See, simply Hamiltonian path. Like 2, 1, 3, 4. If we connect 4 and 5, it will be a Hamiltonian path. Now there are like many ways of solving this question. We can do like two methods, like a 3D method in which we have to see like how many we have to add. Like if it is connected with 0 or it is connected 1, it is connected with 2. Or we can do a 2D method of removal of edges, right? What I mean to say is, for a particular 1, 2, 3, 4, 5, if I remove the edge between 3 and 5, isn't it the same as adding an edge between 4 and 5? It is same, right? It is same. So we have to find the minimum edges we can remove. Means if you remove 3 and 5, it is same as connecting 5 and 4. So simply we have to find the minimum number of edges to remove. So simply we can define DP as like a minimum number of edges to remove in the subtree. Like the only, like it's the basic concept of DP on trace is like either it is connected to the parent or it is not connected to the parent. That's like basic of DP. Yeah, I said basic DP. It's gonna take me like half hour to solve this now. Right. DP of I, comma 0. Minimum number of edges to remove in subtree of I such that it's a vertex disjoint paths. It is a vertex disjoint paths, and there is no edge between I and its parent. DP of I comma 1 is gonna be the same thing, except there is edge between I and its parent. See, writing the DP is easy because in the all the questions it's generally like it's connected with its parent or not. Like thinking of the DP is very difficult. Like the equation. Like the thing is, if there is no edge between its and its parent, so it can have two children. It can have two children, and here it can have only one children. Now let me think. DP of, let us assume there is a node V with U children. So DP of V comma 1. We assume there is no connection between it and its parent. So at that time, and we assume it has two children. मतलब if it has not two children, मतलब it's the same as मतलब dp of v comma 0. So if it has two children, let us assume it has greater than two children. U is greater than or equal to 2. So how many edges we have to remove? U minus 2. मतलब we have to remove all those. No, but the ones we removed, we also have to add the which value of it? The we removed them na. So we have to add the dp of I of 0 value of them. Yes, we have to add the dp of yes, we are going somewhere. dp of I of 0 value, because these are those values, like we have to find the whole subtree na. These are those values of those childs in which it is not connected to this parent, and then but two of them are connected. So we are simply gonna subtract dp of c1 or 1 dp of c2 of 1. Now how can we make this more generic? Is we can make like when I said this dp of u0, it meant not those children, in a way u minus 2. But if I make it u, what should I do is dp of we are gonna subtract it plus it. Okay, let me think. Yes. So if it is initially like this, I'm gonna make another comment. So if you will see later, you can understand. We are gonna add dp of c1. It's like very confusing. 0 to this plus dp of c2. Very confusing. And we are gonna obviously subtract it. मतलब वो तो मतलब common sense है. I'm trying to make a generic function. Why am I subtracting this? I should add this. What the? Why the? Yes. So I am going to cut this from Control X. Now it's clear. Yes, it's clear finally. Yes. What is happening is, initially, let us assume I removed some. I am dp of v1, which means v of 1, v of 0. It is v of 0 here. Like what the fuck? It can have two children. I don't know which two children I have to remove. Well, which two children I'm gonna have it connected with, but the rest I'm gonna remove. If I'm going the rest of it, the minimum number of edges which are to be removed in all the rest of them should also be removed in this. So simply u minus 2 edges I'll remove, but I'm going to add these many edges, which are also removed in all the children which I did not connect it. But I'll also add this, the when it is connected, the edges to be removed in the children which is connected with, and this value, and simply I added and subtracted, so we'll get a more generic value. dp of 0 u minus 2 mm, and plus it's gonna be dp of summation of dp of u comma 0, simple. And we are gonna have, we're gonna add this, subtract this. So plus bracket with dp of c1 comma 1 minus dp of c0 make c1 comma 0, right? Okay, and then we are going to have dp of c1 c2 my bad comma 1 minus dp of c2 comma 0. So simply we want this to minimize, which means we want um, okay, yeah, this much is good enough. We want that minimize, we want to have the maximum value of this term minus this term, like negative of this. So simply the two nodes which we want are gonna have the maximum value of this minus this minus this. And dp of, no, obviously now I can write 1, matlab like that's like very simple now. It's gonna be u minus 1 the summation of dp of u comma 0. Now here I'm gonna write this minus dp of a child c comma 0 1. Okay. Oh, so finally I wrote the dp. Matlab, it was very tedious task, and I think the dp is yes, I'm gonna make a global. I can make a array vector anything I want in dp mx and 2. How much time did it take me to do this? It took me like 20 minutes, like almost 15 minutes to just think of the dp. Like that's like even very slow for me. Matlab. No, simply we are gonna have a function to like make a DFS. Yeah, I'm gonna try to code it quick, as quick as I can. Simply. We are gonna have a DFS 0 comma minus 1. You can pass 0 comma 0 minus 1 minus 2 whatever you want, and then we are gonna simply see out minimum of dp of 0 comma 0 comma dp of 0 comma 1. I don't think that actually matters here, because obviously the answer is gonna be same because it's not gonna be connected with its parent. Well, we'll see. Well, like whatever it is, I'll write in code. So simply, what do we want? We want to have a vector which is going to store all these values, and we'll also have a sum variable which is going to calculate all these values while we are traversing for a particular node. Simply, if child equal to parent, we are going to continue. Because we are coming from child, parent, na? So simply continue. Otherwise, we are going to run like this is like the basic DFS till here. Yes. And then what we are going to add in sum, the value which is going to be returned by your children, dp of child, comma 0. We dot, okay. In we are going to push back what? We have to 0 comma 1, na? Didn't I write pb? Yes, I write pb, so I'm gonna write pb. Why would I not use the macro which I made? dp of child 0 minus the dp of now. So simply we have these values, all these values. Obviously we want to sort the vector in descending order like we did earlier. A dot r begin, v dot r end. We sorted it. And then we are simply going to make two DPs, right? Now what are the possibilities? DP of child. There is one base case I can think that if it is a child node, right? Well, child node, what the fuck? If it is a leaf node, it is not gonna have any children, right? So for that particular case, V is gonna be empty. If V dot if int n is equal to V dot size, and I'm so tired now. My brain is like fucking difficult to think. Like I've been like working all day, went to gym, so if n is equal to 0, it's a leaf node. For that particular DP, I don't of node, comma 0 is equal to DP of node, comma 1 is equal to 0, and we are gonna return because it's void. We already sorted it. Like we can do sort before and after. That doesn't actually matter. I don't think it matters, but still I'm gonna like bring it down here. Then what is going to be DP of node of 0 if it is not a child node? Right now, like DP of node of 0. Now DP of node of 0 is going to be like what I'm thinking is it is possible that that particular node does not have any children. Like if number of children v dot size is greater than 1, right? Simply DP of node of 0 is equal to minimum of DP of node of 0, comma 1 minus 2 plus minus v of 0. I should actually fill this DP with infinite, but yeah, it's filled with 0 now. Else DP of node. Simply this. What I'm thinking is I don't even need to do this minimum of this and this, because if size is equal to greater than 1, so this is gonna be the answer. Otherwise, if size equal to 1, I'm simply gonna store the same value in both of them. You understand? DP of node of 0 equal to I think actually you wrote it without like what the fuck. DP of node of 1. Okay, so it's gonna be n minus 1. It's gonna be same as IVO 0. See, I wrote this minimum because like what I was thinking is if I make both of them equal, right? And then we check if the size is greater than 1. Like if it has a children, more than one child node, then we minimize it. Like if I do that, I don't need to check here for both of them, no? Because already I'm getting the minimized value. Like if I let's like so either I can do it like this or shift on to this minus contention. If I do it like this, first let me see if it will work. First let's see it works. If it doesn't, if it works, then all and good. I will probably play some Call of Duty, like Then I'll sleep. If it doesn't work, I will matlab, change it somehow. I think it should work. Test case event. Go to 50, 60 test case, 100. And it is running so slow now, like 11, 13, like it is checking for each test case. Like a mistake, if can be found a mistake. So anyhow, so I'm just today yesterday was Sunday. So I want okay runtime error. Okay, first thing I'm gonna do. I think in runtime error we don't have to do this, but I'm just doing it for my own sake. Let's try this. If it doesn't work, I'll try the other approach. Yeah, well, I have written everything right, so it should work. Yeah, what the hell is the problem? I mean, the root node should not be connected with its parent, so writing this is crap. Yes. If I want the answer to be like this only, yeah, I don't think it's gonna work. So, well, yeah, it should work like DP if simply both of those values are gonna be this. Like if it's there one child node, we don't have any option. Means we have to connect it. We have to like at least connect it with one. Let's see, I'm gonna like refresh it once. I'm gonna try that. I think the problem is that DP of 0, comma 1 na, it is not connected with its like minus 1. So if I do like that way na, there is some error. That's why maybe it's runtime error because I'm trying to access something which is not there. Like this is properly good. Like if the size is greater than like initially we stored both the values this, and if the size is greater than 1, we're just gonna minimize node of 0, comma n minus 2 plus some minus v of 0. And it should work. Let's see. I'm actually tired now. I'm actually I'm actually grinding Damascus camo now in Call of Duty Mobile. Like I have been doing that for like 250 hours. So I even stopped that for this starters. Like this is going to be my first video on CP. Yeah, last time it stopped at 16, I guess. So like it should go over 16. I am also tired. Like 19, 19. Let's see. Okay, it's again giving runtime error. I'll check it again from the start. First, basically, I made int long. I made constant int max 2e5 plus 69 dp of max and vector int of this. This is all right. 100% right. Test case we include int and size for int. I'm gonna clear that array. For int I equal to 0. Oh my god, bye. That's why we are getting a runtime error. Like, it's a tree, it's a fucking tree, bro. Now I think if this works, if it doesn't work, the other one will work 100%. I think it will also work. It's the same thing. Earlier I was thinking because it is not accessing the parent node, but I thought like it is not even going to make a call to the parent node, no? So that shouldn't be any problem. Let's see the test case running. Let's see 710 50, 13. And so I was saying like Damascus one I've been doing that for 250 hours. Like I haven't stopped that for making this video. Generally otherwise I grind 12 a.m. to 3-4 a.m. Damascus camo. It's 19. Okay, finally. Finally. How many submission did I made of this? Okay, I made 3 rounds. Okay. So it was amazing. So I tried to solve as many as I solved all of the questions. So my main aim was to show like how to approach a question possibly. And it has been like if you want the code, I personally recommend I'll show all the code once, so you can see or maybe take screenshot. But what I personally recommend is like I'll tell you each question, like it's like basic ternary operator, basic question, basic ternary operator, and this is also like basic very implementation. This question is like there's this bit masking property and consecutive XOR. It's like observation question, very easy. Find an integer. It's like if you have done maths now. If you like, the problem is people can go in very wrong ways. So, see the approach I took, minus x minus y. Simply those values will cut and then we'll add this. Simple. It's like DP and bit masks. But these questions are generally asked, like if you go code forces good level, like CD question, DP bit masks is gonna come, and it was a pretty decent question. And first to last, it's a graph question, but it's not a graph, it's a grid question, and it has like basic LIS. It's easy question. It's more of a constructive or something like that question. Elevator, it's a very good question. It's like this is my favorite type of question because it's logical question. Like it has binary search, but this part was logical and interesting. Hamiltonian tree, it is actually a very difficult question. I actually don't think like anyone could be solve this question, like beside me and make a video to explain it. And it took me like a lot of time to even think this DP. Actually, I'm able to solve most of the question. I'm like very good in maths, so I have like that edge. So it was pretty. Also, you can do the different way. Like you uncomment this, you comment this. We remove DP of 0, 1 because 0 is not going to be connected with 1 either way. So all this is done. You can take screenshots. So it was nice. Let's see. So it is 1 hour 34 minutes. It has been a lot of time. So I'm glad if anyone reached till here, and probably will upload more videos regarding CP, some tips and tricks and other stuff. And if you want something like topics like DP, graph, segment trees, anything you want, even FFT, fast Fourier transformation, and any DP optimization, you can ask, you can write in the comments, and I'll probably make a video like once I get very good on those topics. So thank you very much. It was a very nice stream. Okay, bye.